So today we are going to discuss about total internal reflection. Okay, first of all, let's observe this experiment in our daily life, that this total internal reflection actually occurs in our daily life. Okay, let me show one experiment that shows you that how this total internal reflection occurs in our daily life. Okay, okay, now video is visible. So in this video, first we observe that how this total internal reflection works in our daily life. Now we know that we are using glass. If we are using transparent material like plastic or glass, so light will pass through that plastic or glass, right? But it will bend in different direction. Angle will be different because of refractive index, but light can easily pass through the glass or plastic medium. Okay. But in this experiment, we can see we are using a laser light with the glass material, and you can see light is completely reflecting only inside. Okay. So in this experiment, you can easily observe that light is only moving internally, and this shows you the concept of total internal reflection of the light, because you can see light can only reflect from the surface of the glass, and it is only moving inside the glass, right? It is not coming out like in the upward direction, because if it pass through the glass, so it will move in this direction. Okay, but light is not coming out, it is completely reflecting inside. So that is the concept of total internal reflection. Okay, clear? And you can also observe this experiment in the irregular shape. This is the regular one. So light is reflecting inside. And if we consider irregular shape like this, so light can also totally reflect inside the irregular shape. Okay. And if we consider this one in the optical fiber, the internet wire that we used in our daily life, so it will also happen in that optical fiber. You can see that light is moving from one point and it is coming out from the other point. So it is due to total internal reflection. Okay. And this lamp is also the example of practical concept of total internal reflection in our daily life. Okay, clear? Any confusion? Okay, what we need to do, we need to discuss about the theory behind this concept, that how it actually works. And for that, we need to consider a rare medium and a dense medium. So let's suppose if we consider, okay, we are having a different medium like this. On the upper side, we are having air. In the middle, we are having glass, dense medium, and again, we are having air, rare medium. Okay. Now let's suppose if we consider the normal condition of refraction. So you know about the normal condition of refraction, that how refraction works. Refraction will work like this: when light moves from one medium to another, so it will bend towards the medium, or towards the normal, or away from the normal. Okay. So same thing we need to discuss in total internal reflection. So let's see what happens. Let's suppose if we first consider the normal situation. So basically, in exams, they first ask you about the conditions of total internal reflection. So first of all, we need to talk about the conditions. And there are two conditions. The first is light must travel from dense medium to the rare medium. Okay. So this is the first condition, that light must travel from dense medium to the rare medium. It means we need to draw a normal line over here. This will be our normal line. And let's suppose light is traveling from dense medium to the rare medium. So let's suppose if this will be angle of incidence. So from the previous knowledge, we know that light will move away from the normal. Okay. So your refracted ray will be in other direction with greater angle, like this. So this will be angle of refraction. Okay. So in first situation, we can say that angle of incidence is less than angle of refraction. Okay. Because that is the basic situation. And let's suppose if we further increase the angle of incidence, so then what will happen? We consider second scenario, and in second scenario, let's suppose if we consider incident light with greater angle, like this. So what happens with the light? Light will bend with 90 degrees over here. Okay. So we are getting 90-degree. So in this concept, when the at specific angle of incidence, we observe that light will bend at 90 degree. So this incident angle is now known as critical angle. Okay. So we can say that in this situation of incidence is equals to critical angle. And let's suppose if you want to write for the critical angle, so we can say that critical angle is the angle or we can say that critical angle is the angle of incidence because critical angle is the specific or condition, we can say that in this experiment at which light actually bends at 90 degree or slightly reflect also. So critical angle is the angle of incidence when the light beam or when the ray of light bends at 90 degree and slightly reflect. Okay. So this is the concept of critical angle. Any confusion? And if we consider the third situation, let's suppose if we further increase the angle of incidence So the third situation will be like this. If we further increase angle of incidence, so light will completely internally reflect, just like the example we discussed or we observe in the diagram, right? So this light will completely internally reflect, and that is the concept of total internal reflection. Okay. And in second situation, we can say a little bit light is reflect over there. So there is a slight reflection of light also in the second case. And in third case, for the angle, we can say that your angle of incidence is greater than critical angle. And this is the second condition of total internal reflection also. We can say that angle of incidence must be greater than critical angle. Okay, clear? Let me show you one more experiment that will clear this concept, that how these are going to be made practically. Okay, so this is the real demonstration of the total internal reflection, that how light will completely reflect internally. Okay, so if we start the experiment, so you can see that we are taking a glass material for this, and we are having a specific intensity of light. So you can see that at normal, light will move straight without any deviation, without any refraction. So that is the normal condition. But we need to identify the total internal reflection. So initially in this situation, you can see that your angle of incidence is, this is your angle of incidence, that is almost equals to 10. And your angle of refraction is greater than angle of incidence. And that is the first situation that we discussed in our diagram, this first one, that angle of incidence is greater than angle of refraction. And if we consider the second part, further if you increase the angle of incidence, so that will automatically increase your angle of refraction. So now you can see that light is almost at 33 or 35 degree. So we can see that angle of refraction is now greater, and it is equals to 55 degrees, right? So you can see angle of incidence is still less than the angle of refraction, because angle of refraction is greater because light is moving away from the normal, that we already discussed in part 1, that angle of incidence is less than angle of refraction. And at certain angle, you can see that there is a slight reflection of the light. So few of, or we can say that few part of light is about to reflect from the glass, and most of the part of the light is still refracting. So that is our second condition, but we need to make it through 90-degree. So we still increase the angle of incidence till we get the 90-degree refraction. So now you can see that refracted angle is almost at 90-degree. So we got the angle of refraction at 90-degree, and still light is slightly reflecting from the glass material. So that is the example of second situation. Okay. And finally, if we further increase the angle of incidence, so you will find that light is completely reflect back. So that is the concept of total internal reflection. Now you can see that light is completely reflecting back from the glass if you increase the angle of incidence further. So you know the law of reflection, that angle of incidence will be equal to angle of reflection. So this is the concept of total internal reflection. So basically, this topic is related to the concept of total internal reflection, and we observe from the practical experiment that how light completely reflect internally. So in this concept, mostly in exams, they used to ask about the condition of total internal reflection. So we discuss about two conditions. The first condition is light must travel from dense medium to the rare medium. And the second condition is angle of incidence must be greater than critical angle. That is the third condition, that is the third diagram that we draw for the total internal reflection. And further, if they ask about the concept of critical angle, so we already note down the definition of critical angle, that critical angle is just an angle of incidence. It is a specific angle at which light bends at 90 degree and slightly light will start to reflect back. Okay. Any question? Any confusion?
No.
Okay. So basically, this is the concept of total internal reflection. And if we talk about the daily life example, or if we want to write the definition of total internal reflection, so we can define total internal reflection in short as, so basically total internal reflection, total internal reflection is the effect in which light travels from dense medium to the rare medium and light will completely reflect back into the same medium. Okay, clear? Any confusion? Okay, so basically this is the concept related to total internal reflection. Now, let's try to discuss some question related to total internal reflection, that how they ask about the questions in your paper. Okay, if we discuss about some questions related to total internal reflection, and one more thing, if we talk about the daily life application. So in daily life application, if you observe that internet wire that is known as the optical fiber, so when we connect that internet wire in the router or in PC or any other device, so it will start blinking light. So basically that is the application of total internal reflection, right? And we also use this concept in the application of periscope and endoscope. So basically these endoscope and the periscope in the real life, it will be like this. Okay, so basically, if we talk about the endoscope, so endoscope is a device that is used in the medical treatment to observe the internal organ in a body. So there is a pipe, we can say that, or there is a fiber type material that can easily move through inside the body of human being, and there is a camera, there is a light connected at one end. So when light reflect from the one end and it observe at the other end, so we got the clear picture of the internal organ of human being. So like in this way we use one side, because now we are using very modern technology, so at one side the camera is connected, on the other side we are getting the clear picture. But for that we also need the light, because if there is no light, so we are not able to observe the image. So that is the concept of the endoscope that is used in the medical field. And if we talk about the periscope, so basically periscope is usually now used in the submarines. In old days we use these, and we also make this periscope in daily life for the practical purpose, just like this. Let's suppose if you want to observe above from the wall or through the wall, so you use this periscope, because that actually works the same like the submarine, because in submarine is under the water or under the surface of the water. And if you want to observe something over the surface of the water, so just you lift this periscope from the submarine, and that will give you the clear vision of upper surface, right? So this is the concept of periscope, and endoscope. Clear?
Yeah.
Okay, if we talk about some questions, like question number 9, that is related to total internal reflection. Okay, in question number 9, question is a ray of light travels from point X to Y. This is point X and this is point Y. The angle of incidence at Y is greater than critical angle. So according to the condition, we discussed your angle of incidence must be greater than the critical angle. Point number 2. So they mentioned that the angle of incidence is greater than the critical angle. So when angle of incidence is greater than critical angle, it means that light will completely reflect back into the same medium. So according to that, light will completely internally reflect. So it means option A and option B both are not possible. So we need to choose from option C and D. So which option gives you the clear reflection of the light? Is it C or D? C. Because what we need to do, we just need to make a straight normal line. Okay, and from that normal line we can easily measure angle of incidence, angle of reflection. And now you can see that for option C, angle of incidence and angle of reflection both are equal, because when light is reflecting, so in reflection angle of incidence must be equal to angle of reflection. So that's why option C is the right option in this question, because at point C light is completely reflecting with the same angle of incidence, right? Okay, because at D you can observe from the diagram, if we consider this option, so you can see that angle of incidence is greater than option D. So that's why we choose option C, because at option C we are having same angle of reflection after reflecting from the surface. Okay, if we consider some other questions, question number 10. So question number 10, a ray of light in glass is incident on the surface at angle C. The C is the critical angle, which diagram shows what happens to the light. So what happens when light is equals to, or the angle is equals to critical angle? So that is option number 2. When angle of incidence is equals to critical angle, so light will completely refract at 90 degree, and some light slightly reflect back into the same medium. So we need to choose option or diagram number 2, that will give you the clear answer of this question. So which diagram shows you the correct angle of refraction or critical angle? Is it A, B, C or D? So basically in option C, you can see that light is slightly reflecting and light is also refracting, but that is not at angle 90 degree. So this angle is not equals to 90 degree. So that's why we choose option D, because in option D light is refracting at 90 degree, and that diagram is just like the same we draw in option 2 or in figure number 2 in our notes, right? So that's why D is the right answer. Okay. And in option A and B, there is a only concept of refraction only. So that is not possible. Okay. If we consider question 15, so three rays of light are incident on the boundary between a glass block and air, right? So the angle of incidence are different. So we can see one is at angle 20, one is at angle 40, one is at angle 50. So what is a possible critical angle for the light in the glass? You can see at angle 20, light is normally refracting. And in second diagram, we can see that light is almost at 90-degree refracting point, but it is not completely refracted at 90-degree. Okay. So in the third diagram, what actually happens, light is reflecting or light is completely reflecting. So it means that we need to choose the critical angle, and we know that at critical angle, light will refract at 90-degree and reflect also. Okay. So when light is bending at 90 degrees, so it means that angle must be between 40 and 50. So they are asking about the possible critical angle. So possible critical angle will be angle 45, because at 40 light is still refracting and at 50 light is completely reflecting. So the angle or the critical angle must be between 40 and 45. So that's why answer C is the right one. That is the critical angle of the given question. Okay.